senior lecturer here in computer science, so I teach primarily on the computing courses, so that would be primarily computer science and IT. And then I also teach on the master's course, which is a conversion course for people coming into computing from some other degree. If you think since the advent of the internet, really computing has just evolved into every aspect of our lives. So from the smartwatch in your arm, to the smartphone in your pocket, to the self-driving car, to now the advent of robotics, and even now into the area of artificial intelligence. It's never been a more exciting time to really be involved in computing. And we teach the fundamentals of software development, or programming specifically. And this is to demonstrate to students how really all programming is being able to define a solution to a problem as a sequence of steps. And those steps are then effectively written down in a sort of a language that the computer can understand to carry out that particular action. You have to learn the theory, obviously, so we have a small amount of lectures where primarily I demonstrate by actually doing the coding in class. And then primarily it's about lab-based work, so you're given a set of exercises up front before the lab and you have your own time to go and prepare for them. And they're much more confident. They'll have a really clear idea of what they want to do in final year in terms of a project, and we just see them technically much stronger, academically just much more focused, and very, very good reasons. I mean, they're in a workplace environment where they understand what's going to be required of them when they graduate, and then a lot of them come back with job offers. A lot of it now is the larger sort of inward investment companies, and they employ an awful lot of graduates. And then you have a lot of sort of SME, smaller companies looking for software developers, and some of the more futuristic stuff like artificial intelligence now becoming quite pervasive, where companies are starting to look into that. Data science, where companies are looking at this vast amount of data that's been gathered sort of day and daily. You have to continuously learn, and if you don't, you'll get left behind. Now, that's what I love about it. Some people might not like that, but I like the fact that I have to continually sort of run to keep up, because there are just so many new technologies and things. So I think the degree gives you that ability to sort of adapt and then upskill as technology moves forward, which it will do. When students come into computing, we recognise that it's a big jump from the computing that they may have done in school. So we divide the students up into teams, which replicates what they do in industry. And then we use final year students who have applied to sort of be part of this buddy mentoring system. And these students have already been through the whole system, and they understand what it's been like to sit there as a first year, you know. And they act as a mentor to this group of sort of 8 to 10. And they help them engage in the class, they help them when they're running into difficulties, and support them as much as we can, virtually on a one-to-one basis. And then there's nothing nicer than seeing that student sort of riding off into the distance, you know, with a graduate job, and maybe contacting you a year later just, you know, to thank you for everything, or to say I'm doing well and I'm doing this. That's what really makes it all worthwhile, you know.